Hello. I think Karthik already introduced me. I'm Nutan. I'm one of the technical support engineers in Lync. So I support for the courses Class A development of automobiles, and I support for the courses additive manufacturing. Right. Let us move on to the topic, which is additive manufacturing. Right. So which is in the trend now. So what is this additive manufacturing? It combines your manufacturing and your designs. Right. So as a design engineer, so you have n number of creative ideas, right? You have hundreds of thought with you, but every idea cannot be manufactured in your conventional machining processes, right? What we call is material removal process, right? In those processes, what happens is you have a chunk of metal, and what you need to do is you need to remove the material to get your desired shape, right? So we have the basic kind of manufacturing processes like your casting, right? From that, you have your turning, milling, you have your CNC machining, all those things, right? So even though we have all those things, so there are certain parts, right, for aesthetic purpose, right, or for some functional aspects, right? You need to design a part with n number of constraints. So at that particular time, so what happens is your intricacy of your part will be more. So in that case, what you need to do is you need to have some modern manufacturing processes like your CNC machining, right, or rapid prototyping, so which comes under additive manufacturing. So this is the new era of manufacturing your components, right? So that is the introduction about your additive manufacturing topic. Next, moving forward, so here we can see one of the beautiful images that we have, right? So in this particular beautiful image, what we can see is so how intricate your shape is, right? With this intricate shape, what you can do is you can manufacture this intricate shape without any problem, right? So this is why we use additive manufacturing, right? These kind of fins or the shape, right? And in additive manufacturing, what we do is we do a layer by layer process, right? We'll have one layer, and we'll put another layer on top of it, and another layer on top of it. So all these layers are layers of materials that you have, right? We'll discuss about all those things in the later slides. So the introduction for the topic, which is your 3D printing, right? So it is also called as your additive manufacturing, where you have so two types of processes, basically manufacturing process, right? So one is your subtractive process, right, or material removal process. Your turning, your milling, your broaching, your all the even CNC machining. It is also called as your subtractive machining, where you have a chunk of metal or a part, and so what we call is billet, and we take that billet, and what we do is we'll try to trim off excess parts which are not needed for us to make a product, right? So but what is the con of that particular uh, type, right? You'll have a loss of material, right? So you have a very bigger chunk, and you're cutting off material, right? It is time wasting, one of the important thing, and the cost of the manufacturing, right? You're wasting a lot of material, right? And third one is your material which is being removed, right? It is waste, and this particular waste should be processed once again, and then it needs to be what we can say is it needs to be converted into raw material once again. It's a very big process, and you have a lot of wastage. So in those cases, this 3D printing will be much more helpful for you. And one of the important fact is your intricacy of the part. So if you have a part which is very intricate, right, for the you can see in the image that we have in front of you in the slide. So this is one of the parts which is being 3D printed. So is it possible to manufacture this particular part in any of the manufacturing processes without any hassle? No, right? It's a little complicated way to manufacture these parts, right? And there are a lot of parameters while manufacturing too. So taking care of all those things, right? 3D printing is the future of your manufacturing process, right? So what is the definition then? So more formally known as additive manufacturing, right? 3D printing is formally in industry known as additive manufacturing, is creating a physical product from a 3D model. You'll be having a CAD model, you'll be having a 3D model of certain part, and you build layer by layer that part, right? Using a 3D printer. So that is called as your 3D printing, right? So why 3D printing was invented, right? There may be a question. Okay, we have, you know, n number of manufacturing processes, right? Your casting is there, your CNC machining is there, the modern kind of things, right? Even though, why did we, started using this 3D printing? So the first and primary use of this 3D printing was for aesthetic purpose, right? What do you mean by aesthetic purpose? It's for visual. So our part should look good for the buyer's eyes, right? In that particular case, right? And to prototype something, right? You have designed a certain kind of turbine or a gear maybe, and you need to make sure that you're displaying it or showing it to someone. So this is how my product will look like. So in those cases, so it's a very hard process to, build that particular component, build the, mold core cavity for that components, or the supporting jigs and fixtures for that component, or all the supporting mechanisms or the processes which is included in those in that particular component, right? So if you want to manufacture a plastic component, what you need to do is you need to first, design that component, and after that what you need to do is you have a lot of things, right? Like your injection molding machine. In the molding machine you have your core and cavity, right? And your ejector pins. So all those things. So as an engineer, what you need to do is when you design this particular plastic part, you need to also design all of these things to know to make it manufacturable, right? So in those cases, right, to just to show one single piece or just to manufacture one single piece, it is much useful for you to, use this 3D printing technique rather than the conventional methods, right? So moving forward now, right, in the modern era, so 3D printing has evolved so much that even for mass manufacturing, right, mass production, we can easily use it without any hassle, right? So moving forward, right? So why do we use 3D printing then, right? So we know 3D printing is a layer by layer method of, building your component and aesthetic purpose, all those things. But so why do we use? Why did this 3D printing invented, right? So one of the first points is ability to produce complex shape, right? You have a shape which is very very complex, right? For example, so we have seen, some of the blades used in your turbines, right? Your turbines rotor. So in those cases, those blades, to prototype those blades, it's very hard, right? In even in CNC machines too. So there are some components where the gap is so low. So your gap may be 1 mm, 2 mm, or within 1 centimeter range, and your tool size is more than 1 centimeter or 2 centimeter. Then in those cases, it's not possible for us to manufacture those particular component. So at that particular time, what we do is we use this 3D printing method, right, in the beginning. And after for mass manufacturing method, we can engineer some modern manufacturing processes according to the use, right? The first and foremost thing is to ability to produce complex shapes, right? So what is the second thing? Second is less materials needed, right? To 3D print a material, you only need the material which is required for that particular, to produce that particular component. That's it, right? You have a resin, or you have, wires, we call them wires of material, right? Spool. So you have those spool too. So what you can do is, you can put material on the places which are necessary, right? Apart from those places, you can remove your nozzle, right? Only the places which are, there, you are putting only materials only on that particular parts. So that's why, you consume very less material, right? So, and so you print in 3 dimension, right? So you're putting only the material which is necessary. Apart from that, it's much easier for you to create your holes and all the other stuff. So that's why, less material is needed. Next, low manufacturing time, right? So when you want to make a prototype, for example, you designed a robotic arm and you need to, show it to somebody, right? Manufacturing or prototyping, right? When you want to prototype a certain part, what happens is, so you're designing a part in CAD model and you're building, some of the uh, necessary parts which are needed for that particular part, right? Supporting components. And after, designing these supporting components, what you need to do is you need to send it for a manufacturer, which can, mill it, turn it, or do some, subtractive manufacturing process. And then you need to get that particular component back. You need to assemble it. So there are a number of steps which is inside of it, right? So what we can do is we can, 3D print this particular part, right? While 3D printing, what happens is all the time which is necessary, which is, eating your time, right? Your prototyping time, right? Sending it to your manufacturer, he's, first tooling it, so we call it tooling. So he'll start to tool your product first, and then he'll see, okay, is this possible to manufacture? And then he'll give you an idea, okay, this is how we manufacture. He'll select the material, all those things, blah blah blah, time taking, right? So instead of that, what you can do is you can design your component by yourself, and you can, just print it by yourself, right? By lowering your manufacturing time. Next, easy prototyping, right? So what is the prerequisite for, 3D printing? It is just your CAD modeling skill, that's it. So if you are very good in CAD modeling skill, and if you are very good in, uh, you know understanding the geometry, understanding this 3D printing application, then I think you're set. I think you're set for your 3D printing, right? So that's why we call it prototyping, right? In the beginning of the times, what we can do is, if you want to prototype some particular part, for example, your bottle, right? You have your CAD tool, and I think apart from that, you need a 3D printer. That's it. So you don't need any other things to, prototype your 3D printing parts, right? Next, you have the wide range of material, right? So wide range of material in the sense, you have your plastics, right? In the plastics, you have n number of types of plastics, and you have your plastic resins, right? In plastic resins too, you have n number of plastic resins. And then metal, you can now, in this modern era, you can 3D print your metals too, right? You can make a powder of your particular metal, and, by using lasers, we can join those metals and we can 3D print them, right? So you have wide range of materials. Next is your wide range of application, right? What do we, mean by wide range of application, right? So any field where you have a product, right? Any field, in case, not just your mechanical engineering field, right? Or your manufacturing field, right? Even electrical field, even, biomedical field, even computer science field, right? So in computer science field, when you want to build a computer, right, you have your product, right? In that cases, or you have a software which slices your part, then what you can do is you can, develop that software. If you understand this 3D printing, how this 3D printing occurs, right? You have n number of applications. When you want to develop some certain concept or a certain part or a product, what you can do is you can use 3D printing in that particular application, right? Next, so now we talk about rapid manufacturing, right? So there is a difference between your rapid prototyping and your rapid manufacturing, right? So rapid prototyping is your 3D printing or your additive manufacturing, basically. So this comes under your rapid manufacturing, where, so in the beginning of 1960s, what they did is, they tried to automate some things, right? It's much easier for, so to reduce human risks and human effort, what they did was they, tried to build this automation feature, right? In those cases, they developed CNC machines, right? NC machines and CNC machines, all those things. So in the era, this particular rapid manufacturing bloomed, right? So what do you mean by rapid manufacturing then, right? It's a method of manufacturing which enables fast and flexible production and prototyping. So when you want to, prototype something, right, it's not easy, because I explained you, I think, one or two times, right? You need to create all these supporting necessary manufacturing components with your product, in that particular time or in that particular case, what happens is it's not easy, right? It's not easy or it's not fast, right? It's a very slow process. It'll take 6 months, 1 year, maybe 2 months too, right? In those particular cases, right, for prototyping, it's much easier to use this particular rapid manufacturing technique, right? And it enables the integration of software tools and hardware machines for a better workflow and an efficient manufacturing process, right? So when you have a manufacturing process which is running on, right, there may be chance of errors, right, from human intervention, right? So when we have a software to closely monitor these kind of errors, and when you have this automated hardware system, which is imagine a CNC machine, you already have your automated tooling system where your tools get automatically selected, and what your tool is, your tool will directly go into near your component, and your tool will start to mill out the part or remove the material. So there is no human intervention in between, right? So in that particular case, it's a very faster process and it's a very efficient process, right? And even also it will reduce the human errors, injuries, right? Risk, what we call in the industry. Next, so examples are your CNC machine, your injection molding, right? Automated injection molding in the modern times. I think you have seen in you know uh, your National Geography channel maybe. So in the injection molding machines, it's completely automated, right? Where you see factories. So that is also comes under your rapid manufacturing. Next is additive manufacturing and 3D printing, right? This is one of the newest addition for this rapid manufacturing systems. Next, right? So I think all of you can see my screen, right? So this is an impeller for a motor, right? So when this impeller is produced, right? So it's a very difficult task, right? Why? Because you have grooves here to reduce the thrust, right? To reduce the radial thrust, you have grooves here, and you have your turbine, which is located housed inside, right? This groove will go from inside of the material to the outside of the material. So in this particular case, it's very hard for us to manufacture this component, right? So, or when you want to mass manufacture it, you have to you know have some set of tools which are which will make it easier for you to develop this component or develop this particular part, right? But you want to make just only one single part of it, right, to show somebody. So it is not worth it, right? So in these particular kind of cases, what you can do is you can use this 3D printing method. Right, moving forward. And also here you can see the support system that we have, right? When we want to print something inclined at an angle, what we do is we'll give this support kind of system where it will support your material too, right? We'll understand about those things later in the part. Next, right? So conventionally, this is one of the topics which is discussed a lot, so I'm not gonna take a longer time to discuss these things, right? The techniques, right? You have a number of techniques in your 3D printing or additive manufacturing process, right? And also these techniques are your technologies which is used in 3D printing, right? Or rapid prototyping. So what are those techniques and technologies then, right? So your techniques and technologies are stereolithography, right? Which is also called as your SLA process. So what is this SLA process? What does it do? So you'll have a resin, you'll have a mix of resin which hardens under UV light, right? When you put ultraviolet light to that particular resin, what it does is it will harden. So by using this principle, what we can do is, so this part is produced by that particular resin, right? So what you can do is you can harden the resin at certain parts, right? If you want to create this kind of shape, right, what you can do is you can harden resin only at these particular certain parts, right? By this, what will happen is your layer is built up, and subsequently doing it successively, right? Continuously, again and again and again and again. So when you do these kind of thing, right, with a structured approach, then you'll get a component. So it is called as your SLA process, right? So is my screen visible? Can anyone?
Yes, Nudan, it is visible.
It is visible, right? Great, great. So stereolithography uses the principle of hardening your resin, right? So what is next then? Next is your selective laser sintering. So instead of a resin, right, what we have is we'll have a powder, right? In this particular case. So in this particular case, we are using a laser and a metal powder, right? So instead of a metal powder here, what we do is we'll use a plastic powder, right? You have plastic, you have ABS, you have PLA, you have PEP, right? All those material. What you can do is you can put the powdered material here, and then you can, selectively, burn it so that it will melt and stick to the parts, right? When you selectively melt it, so it will take a solid shape or a rigid shape. And then by doing it continuously again and again and again, you'll get your particular part or the component or your product, right? This is your selective laser sintering. You are using a laser to sinter your product, right? When do we, so when we say sinter, right, sinter is melting the part and hardening the part, right? When this laser comes and touches your part will melt, and when the laser moves out, this part will get hardened once again. So because of this, your material is built up. Next, you have your fused deposition modeling, right? So this is one of the common machines that we see in our daily life, right? I think everybody has seen this 3D printing machines in their colleges or in the internet or in some fest or something. So in here, what we do is we use this fused deposition modeling. So what does this do? This will have a spool and will have a wire of material, right? So what we do is we'll extrude this material via a nozzle. So we'll be having a nozzle and you'll be having a spool of wires like this. So we'll take this particular wire and we'll melt this particular plastic part, right? Plastic wire at this particular nozzle, and we'll try to extrude it, right? And building this model in Z direction will give you your component or your part. So that is your fused deposition modeling. So I think fused deposition modeling is one of the common technique that we use because it's very cheap, it's very affordable for everyone, right? And for prototyping, it is one of the best process that we have right now. There are some cons, but this is one of the best methods for a beginner or a hobbyist. So this is one of the important things, right? Next, we have laminated object manufacturing, right? A best example is your paper. So you take a paper, right, a plastic sheet or a paper, right, and you apply glue on top of it, right, glue or gum, and you put another paper and you cut it for a certain shape, right? And you do it again and again and again. You put another layer of paper, you cut the paper once again, you put another layer of paper, you cut the paper once again, you put so hundreds of layers of this paper and you cut the layer of papers to get your ultimate product, right? So this is one of the components which is done by laminated object manufacturing, where all the lines that you are seeing here, right, all these lines are your individual paper or plastic sheets, and you have gum or glue in between them, right? Or some kind of resin. We can use some kind of resin or we can use some kind of glue. And then when we cut them at some particular angle and at some particular shape, then you'll get this kind of part, right? Next is your direct metal laser sintering, right? So in here, what you do is you have a metal powder. So it is very related to your selective laser sintering, but instead of that, what you will do is you'll use a metal powder. So in here, you have your metal powder and you sinter your metal powder wherever you need, right? By using a high powered laser. Here, the laser is very high powered and the temperatures will go up to 700, 800 degrees Celsius. And by doing that, what happens is your metal powder will melt and stick to each other, right? And when the laser moves away from your particular powder part, what happens is your powder cools down and you'll have your rigid particular part, right? So these are all the techniques, right? These are all the basic techniques that we use in, 3D printing, right? I think these are the common things. I think most of you, all studied this in your colleges or in the any of your, engineering life. Next, we have the steps involved in, 3D printing. So I think these are the same points too, right? You have a number of steps when you want to 3D print some object, right? It's not just like you created a CAD model and then you just print it in your 3D printer, right? You need to process, right, your product or your part, right? We have one pre-processing part and we have some post-processing part, right? So all of these are your pre-processing part. So in the pre-processing, what we do, right? Before printing the material, what we'll do, right? So first step is we'll develop a 3D CAD model, right? By using any of your softwares, right? Like CATIA, SolidWorks, right? NX, something. So by using all these softwares, what you'll do is you'll develop a 3D model, right? You have your CAD model. So what do you mean by CAD? Computer aided design, right? You'll have your model. Next, we call the particular point as tessellation. So tessellation is, you know, uh, so imagine this is your cube. So what we'll do is we'll try to tessellate this, right? By converting this cube into some tessellation factors like your rectangle, sorry, triangle, right? We'll try to cut this into a number of small parts so that it's not a burden on your machine, right? It's a, when you want to, make this particular part, what happens is, if you directly input this whole cube, it's not good for your machine, right? Your machine won't understand, right? You need to convert into an STL file. So STL is standard tessellation language, right? It's a common format for all the, 3D printers. It will try to tessellate or convert this into smaller geometries. So tessellation means converting into smaller geometries. Next, you have your STL file, which has to be sliced, right? So once again, taking the example of a cube, you won't print this cube in only one single shot, right? So this cube is now next is sliced because we are printing layer by layer. What we do is we'll slice this particular object like this with a number of layers, right? What is the layer thickness? The layer thickness will be your slicing thickness, right? When you slice this particular model for a certain thickness, which is called as your layer thickness, right? One single layer will be that particular thick, right? Next, you'll build your model. So these are all the things which are in your pre-processing, right? Next comes to the part of, building the printing bed, right? You have your 3D printer and your 3D printer will have something called as your printing bed. So on top of this particular printing bed, what you do is you'll print your model, right? You need to, you know, build that particular printing bed. The printing bed will have some of the parameters like the roughness of the printing bed, and the temperature of your printing bed, right? And the stickiness of your printing bed, and the printing volume. You need to configure all those things, right? Those are all included in the building of the printing bed, right? Next, building your model, right? You have your model now, right? That needs to be printed in your 3D printer, right? You have your printing bed and you need to print this particular cube. So that is called as, building your model. So this is one of the crucial parts, right? This is called as 3D printing, right? So you have, n number of layers. You have n number of layers and you need to make sure that your machine or your 3D printer is printing these particular parts, right? With the proper guidelines, with the proper parameters, with the proper, temperature, with the proper extrusion factors, all those things, right? This is where your actual manufacturing, your actual modeling will happen, right? So next comes the part of, post processing, right? You have built your part, but what you need to do, your part is rough, right? In the case of your part is rough, what you need to do is you need to sand it out, right? You need to make sure that your product doesn't have any gaps. And if you need holes, right, you have support structure, you have holes, you have, a lot of things with your particular model. You have something called as brims, right? You need to remove all those things, and you need to polish these things. You need to paint this one, right? So all those things are called as, your post processing stuff, right? Next, so these are the steps involved in 3D printing, right? The steps, the techniques are, conventional, right? In the colleges, in, all the sources that you get, these steps are, repeated again and again and again and again, right? So from now onwards, we'll talk about some interesting stuff with respect to 3D printing, right? So apart from all the conventional things that we thought, so as an engineer, what you need to do is you need to design your parts, right? To make the part manufacturable, right? If you're just manufacturing this particular part, then it's not worth it, right? So if not for the proper guidelines, your model will not be built accordingly, right? You need to make sure that you're building your part too. In those cases, what you need to do, you need to design it with some certain guidelines, right? And you have a number of manufacturing applications, a number of materials, and a number of techniques too, right? For each and every techniques, there will be some common points. We'll discuss about those common points in this particular part, right? So what are the issues that we face while we are 3D printing, right? That is one of the hot topics going on right now, right? So what issues do we have with respect to, our 3D printer and 3D printing or our parts too, right? Every machine will not be, you know developing that same particular part, or it will not be having, the same particular concept behind it, right? One of the important things are your build direction, right? So we'll discuss about this thing later, right? So build direction of the part. Next is, overhangs. When you have something which is hanging or with a slope, right? Steep slope, this particular problem will occur, right? And the contact area, right? I told you about the build plate, right? When you are putting some object on top of your build plate, what you need to do is you need to make sure that the whole surface is touching your build plate, so that this surface will stick or adhere to your build plate, right? When this particular surface will stick to your build plate, then it will be stable, right? For the vibrations, right? For the vibrations or any disturbance which is happening in your machine, right? Your model should withstand all those things, so that it should have a good contact area, right? So, and next is your post processing may be required, right? All the models are not perfect, right? Your models will have some surface impurities, right? Surface uh, problems, right? And when you have holes, your holes may not be finished properly, or you have some gaps in between, or your part is not properly melted, right? All those things may occur when you are 3D printing some particular part. So how to tackle these things, right? So these are the problems that we face when we are 3D printing some particular part. So how to tackle these things, that we see in the next slides, right? So all those particular, problems we saw. So how to tackle those things then, right? So one of the important topic is your build direction, right? You have a direction to build. You cannot randomly build on your 3D printer, right? So in the case with this particular model, right? So what is the build direction, right? So this is just a model. You don't have proper orientation for it, proper direction or the datum points for it, right? In this case, if you build this particular method vertically, what will happen is it will fail definitely, because at this particular point, or at this particular point, you don't have sufficient material, right, to hold, to support, or to hold. You don't have any sufficient material, right? And even if you build some supports, what will happen is this will, tilt in some angle or direction, right? When you are putting a support, right, and your supports are costly because you are wasting a lot of material on unnecessary parts, right? As an engineer, what you need to do is you need to think, okay, so my part is like this, but what I can do is I can place my part like this horizontally, So instead of vertically, I can place my component horizontally so that it will print in this particular manner, right? And will not be having any supports or any other structure which is not necessary, and will save a lot of material, and my parts will be accurate, right? The reorientation. So simply saying, the reorientation of the particular part can solve this particular problem. Next, when you have steep slope or overhangs, right? You have a part, right? For example, you have this particular chair, and if you're manufacturing this chair directly like this, so this will be your bottom, and you're building your chair on top of your build plate like this. So what happens? You have your cylinders here. So let us assume that, okay, it's easy to build this particular cylinders. Then on top of that, you have your seat, right? What happens when you are 3D printing your seat, right? Your seat will not be having any support at this particular region, right? Your seat won't have any supports at this particular region. So in this case, what will happen, right? This particular material will go down, right? It will spill, it will go down, it's wasted, right? In this case, what you need to do, right? So this is one of the important topics. Then you need to give supports like this. So in this particular image, as we shown here, right? So you can do one thing, that is, you can build supports here, right? What are supports? Supports are the very thin material which is which acts as what I can say, holding member for your particular object or your part, right? For the example, here you have a bridge kind of shape, right? A bridge kind of shape, and when you want to print this vertically, right, what will happen is, when you are printing this one, this will sag, right? No material will be deposited on this particular point. In that particular case, what I can do is, I can design a particular part, right? I can design support like this so that it can hold the load of this particular bridge or the overhang, and then it can support them, right, without causing any trouble, right, and without losing any material too. That is one of the important things too, right? Or else it will try to sag like this, or else it will take a lot of time. We don't want all those things. We want it as soon as possible and as efficient as possible, right? Next, you need to have a good contact area, right? So I told you about the contact area. You need a lot of contact area to make sure that your particular part is sticking to your build plate. If it is not sticking, then what will happen is, so in this example, if you want to, print these things, right, your nozzle will move in this direction a number of times. So what if in between accidentally it knocks over some particular point, and then if you don't have sufficient support, it will fall, right? We don't want that to happen. So what we do is, we'll give brims like this. So this is called as your brim, right? We'll give brims like this, right? So what are the supports brims are in common, right? Have in common, right? So these are parts that we don't need, right? So these are some unnecessary parts, right? So it is printed very thin, right? This is one layer thick, very thin. And after building my part, in the post processing operation, what I can do is, I can use a cutter and I can trim these parts out, right? I can remove them so that my parts will stay intact, and after that I can sand them, or I can use some acetone to clear them, right? So next is your post processing. So as I mentioned, so your part will not be perfect all the time. So in that particular case, what you need to do is, you need to have some of the post processing operations, like painting your model. You have to fill the gaps, you need to drill some holes, right? Or you need to sand your part, all of those things, right? Or chemical washing, right? Chemical finishing by using acetone or some other kind of solvent. You need to do all these uh, operations in order to get a very good or smooth model. Next, so now we talked about the problems and how to tackle those problems when you are 3D printing. As a beginner and as an engineer, you need to make sure that if you are printing some parts, you are understanding the troubleshooting, understanding the factors, right? Problems, what are the problems that we, have in our model and how to troubleshoot them, right? So now you need to think like a professional engineer. So what are the parameters which is in your 3D printing, right? Why is it given? How it is given? What does it mean, right? When you have these kind of points, then it will be much nicer and beneficial for you to understand all of these 3D printing techniques, right? So, and one of the important things is now, as your 3D printing techniques are developing and your process are improving, right? You need to make sure that your product will withstand the, you know, test of strength. Your part should be reliable, right? Your part should be, affordable, reliable, and the third one is strong. Your part shouldn't fail at some certain point of time, right? In those cases, right? And there may be some intricacy in your model. So in those particular cases, you need to simplify those things, right? If you have a very intricate component, then what you need to think is, okay, how to design my component for that particular shape, right? How to design my infill, how to design my support structure, or how to design some of the parameters. What is the thickness, right? So what is the thickness that can withhold that particular shape? So in those cases, what you need to do is you need to understand these parameters in 3D printing, right? So what are the parameters then? So you have your infill. So infill is the filled volume. If you have a box like this, right? So while 3D printing for aesthetic purpose, what we can, so we cannot always, print a solid one, right? So what happens if we print a solid one? We are losing a lot of material inside, right? We are losing n number of time hours which are spent, because putting material in this particular spaces which is not necessary, right? If you're designing a component for aesthetic purpose, it's not good or necessary to fill out this particular part. So we have parameters for this infills then. So we'll talk about these infills later, right? So iterations of your design, right? Your design is not one single, component, or what I can say, one single idea, right? So if you want to design one simple screw, what you'll do is you have a number of parameters, right? What is the tightening torque of that particular screw? What is the diameter of the screw? What is the length of the screw? What is the material for that screw, right? So those are called as iterations, design iterations. So similarly, you have your 3D printing parameter iterations, right? So what is the material that we need? What is the amount of infill? What is the ratio of your wall thickness, right? And what is the kind of layer height that you need? So where do my material is more? Where should I put my material more? Where should I remove my material more? So should my, design oriented towards aesthetics, or my design is oriented towards practical usage, right? When you talk about all these things, so it comes under your iteration of design, right? Next, your slicing thickness, or we call them layer thickness, right? When you're 3D printing, what you're doing is you're putting material layer by layer, right? Like this. So when you want to put layer by layer like this, so you have some thickness of your layers, right? You need to make sure that your layer thickness is maintained, or there are parameters where, how your layer thickness affects the strength of your component or the final finish of your components, or we can say resolution of your components, right? If you have a very low resolution, then your component will be, a blocky model kind of a thing. And if you have very high resolution, your model will have a very high finish, right? Finish tolerance. So in those cases, you need to make sure that you are understanding this layer thickness too. And then you need to move forward with this particular parameter, right? And you have the wall thickness, right? What is wall thickness? The thickness of your exterior wall, how thick it should be, right? It shouldn't be too thin. So if you're using this particular part for some application, and if your layers wall thickness is too thin, if you just touch it or hold it in your hand, what can happen is it can break, right? So in that particular case, what happens is you need to increase your wall thickness, right? If you're building a robot and if you're building an enclosure for your robot, right? If your robot PCB lies inside your enclosure like this, right? And if your robot, falls, so what happens if you have a very less wall thickness? Your robot will break, right? So I'm relating it with the common building things that we do, right? If you have a very little wall thickness or less wall thickness, what happens is when something bad happens, this will break instantly, and you need to make sure you need to produce this part once again, right? But if you are putting a bigger wall thickness, what will happen is you'll lose the storage volume, the first part, and second is your model will become bulkier and you lose a lot of material, right? We don't want that too. We need to have our cost in check too. Then we need to find a sweet spot where both of these things will occur at the same time, right? So that's why we take wall thickness. And next we have the nozzle diameter, right? So when we talk about this nozzle diameter, right? So when you have a very smaller diameter nozzle, right, it will have a very finer layer thickness. And when you have a very bigger nozzle, it will have a very uh, larger layer thickness. So how it will affect with your resolution of the model, that comes in that particular case. Next, how your load is. So some of the parameters that I'm going to tell, right, those are not included in the slides. So what are the other parameters? How your load will be, right? So how the load or the application of your component. So for an example, you're building a component like this and you're applying a load like this. So how should your layers orientation be, right? That is one of the important question. Because so what happens when you are putting a load like this, right? Your layers or your component should withstand this particular load, right? So your layer should be aligned like this. So what happens if your layers are not aligned like this, right? If your layers are aligned like this, right? So when you're applying a load, right, if these layers are not properly cured, right, when you cure this particular component in UV or in some certain temperatures, and if it is not properly cured, then what happens when you put a load like this? It will split into two particular parts, right? Two single parts, because your layers are not strong enough. But when your layers are like this layers will oppose this particular load. Your layers will be strong, right? So this is your slicing parameter too, right? When it comes to the layer thickness, this is one of the important parameters when you slice to how should your component layer should be, right, in the orientation part. Now, so we'll look at all of these things in a little detailed manner, right? What do you mean by infill? What do you mean by iterations of your design? What is your thickness? What is your wall thickness? What is your nozzle diameter? All those things, right? So infill, when we talk about the infill, we talk about percentage density, right? For example, as you can see here, right? So we have one same component with three kind of infill. One is 12% infill, one is 30% infill, and one is 50% infill. So what do you mean by infill? Sorry, guys. So the amount of volume, taken by the material, right? So that is called as your infill, or how solid your part is, right? So if you're using this part just for showing purpose or aesthetic purpose, right, what we can do is we can use a minimum infill, that is your 10%, 10% to 25% infill, right? So only for aesthetic purpose. So you're not putting any load on it. You're just showing this component to someone. So for example, right, you printed a robot, a car model, right? You have a car model and you're just showing the exterior of the car, right? For example, you have your car model like this, and you're showing the only exterior part of the car. So you don't need to show the interiors, right? So what you can do is you can directly print half the car part and just show the exterior of it. But right, for aesthetic purpose only, right? Or when you want to make this hollow, right? In the case of filters and all the other stuff. But if you want to make your part for some function, right? Your part should have some strength. In that particular case, what you need to do is you need to put some more infills, right? Put some more rips into the model. These are called as rips, right? You need to put more rips so that your part will be strengthened and it will withhold all the loads which is necessary, right? And if your part is, fully for structural application, it should withstand a large amount of load, something similar to that. Then what you can do is you can give the infills from 50 to 100%. So what do I mean by 100% infill? There'll not be these kind of whole things, right? It'll be completely filled up to the brim, solid, right? So this is your infill. Infill has a very, bigger effect when when you're designing for your structural components or some functional components. Next, right? Iterations or iterations of your design, right? So what is iteration? Iteration is just going back and forth with your parameters or your design, right? So you have one design, you don't want that design because the design is bad or it is not performing well. So what you do is you go to another design which supposed to perform even more. So you found out that okay, that is not performing well too. What you do is you'll do another model which improves the performance even more, like that, right? You have hundreds of iterations, right? So in 3D printing, so one of the examples that I can give you is your strength to weight ratio, right? Your part should have a allowable strength for some allowable weight. Your part shouldn't weigh too much, right? What happens if it's way too much, right? It will have a lot of material which will cost you, and it will take a lot of time to print too, right? When you have a lot of material, it'll take a lot of time to print, right? So it is not worth it, right? So what happens if your material is very low in weight, right? It is only used for aesthetic purpose, right? For showing, right? But if you're designing a component for your application or a functional use, then that particular component will not uh, you know will not be going to any practical use, right? Or it won't be having a proper strength. So in this particular case, what you need to do, you need to make sure that, so in this particular example, what we did, so what we did was, so in here we have a complete material with completely solid parts, right? This is completely solid, this is completely solid, and all the rib thicknesses are much higher, right? We wanted to reduce it, right, by compromising, right? We reduced it for a bare minimum to look, okay, is this particular part is performing properly, right? This part was not performing properly because it had a very less thickness and low strength. So what we did was, so from this we got to know that okay, some certain areas we need to improve the strength, right? At some certain areas we can remove material. So in that particular case, what we did was, at these particular points, right, we added some materials, right? At wherever our edges are, we added our materials, and wherever it was not necessary, like these parts, right, we removed material, and even these parts. So if it's holding something, then we don't need any material in between, right? In this particular case, what we can do is we can remove the material. So guys, so this is not a step that you can do is one single approach, right? One iteration. So you need to do the iteration 2 times, 3 times. So most of the time as a beginner, it may happen for 5 to 6 times or hundreds of times too, right? So in these individual iterations, what you're doing is you're developing your model. So this is called as your iterations. So these iterations are one of the important factors in the case of 3D printing, because you need to 3D print for some certain application or some certain purpose. Then what happens is your designing skills, right, and your analytic skills that come into play to design your component for a better success. So next is your layer thickness, right? So as you people can see in the image, right, so you have layers. So when we talk about layers, right, so I told you, so when the layer thickness is more, so what happens is your resolution of the model decreases, right? The resolution decreases, so the quality, right? If you have a very high resolution, what happens is your quality of the model will be, much more. The resolution of your model will be much more, right? It will be much more smoother, right? And in this particular case, what is this? So here our layer thickness are very fine, right? The layer thickness are maybe in the range of 0.05 mm to 0.15 mm, in those ranges. Then what happens is your model will be highly clear, right? Highly finished model. But the problem is when you have that less of a layer thickness, it'll take a lot of time, right? It'll take a lot of time. And one important factor, right? When you have a very, good layer thickness, right? Very uh, good layer thickness in the sense, very thin layers, then the strength of your model will be much more than thick layers. Why? Because you have much more layers to withstand that particular load, right? So that's about your layer thickness. So next is your wall thickness, right? We talked about this wall thickness. So when you want to manufacture or 3D print a part, right? This, like this, right? So it's a shell, right? A hollow part, or we can call it a shell, right? If you want to 3D print this part, so you need to, so if this particular shell is very thin, what happens is it will fall down, right? One of the things. But in here, what I'll say is I'll give a support here so that it will withstand that particular sagging or the falling, right? Or, um, the deformation in our body. But what happens after that, right? When you are removing the support material itself, what may happen is, because this is very fragile, when you push it, it may break, right? In this particular case, what will happen, right? Your model is very weak, right? And if you are designing this particular component for some particular purpose, right, then it is very, very necessary to maintain a certain wall thickness, right? So that's about your, wall thickness and shell thickness. What does it do then? So it strengthens your part, or it strengthens your model, so that your model is not just for aesthetic purpose, but for your functional purpose too, right? And there are some criteria for minimum wall thickness, right? The wall thickness should be in the range of 1 mm to 5 mm if it's for aesthetic purpose. And your infill, right, this should be around 12 to 15% for, for an aesthetic model. And if you're creating a part for some certain wall thickness, sorry, some certain function, then you should have some certain wall thickness which is associated with the strength of that particular model. And you should have some certain infill, to have in your particular to, support that particular function, right? So that's about your wall thickness factor. So next is your nozzle diameter, right? So when we say about your nozzle diameter, right, when your nozzle diameter, so we have some standardized diameter for the extruder, so which is your 0.8 mm, which is the bigger nozzle, right? And you have your 0.4 mm, that is the most used nozzle in 3D printers. And for finer finishes, right, finer models, you have 0.2 mm nozzles, right? When you have this 0.2 mm, you'll get a very thin layer. You'll get a very thin layer, but you'll take a lot of time, right? Even when we talk about this nozzle diameter, we talk about time too, because when you have very small diameter, right, a lot less material will be extruded from your nozzle. And because of that particular uh, case, the time will be increased, right? And you have a very big nozzle diameter, then your strength will be less in your particular model because of the layer thickness, right? Next, when you have a larger nozzle, right, what happens is more material will be produced, will be added to your particular material, sorry, particular part. And with that, what will happen, right? Your material will be bigger and it will cost more, right? There should be a compromise between all of those things. So this is about your, parameters in 3D printing. When you want to 3D print, so these are These are the important parameters that you need to take in your mind so that you are producing your part for some functionality or some application, right? Next, we have our post-processing parameters, right? So you have done the model, right? You have printed your model. So how to process it, right? Because your model will not be having very good finish, or it will have some supports that we have put in because we need to have some strength. And next we have some brims, right? We have given the brims, and because of this layers, right? We talked about the layer thickness. So in layer thickness, what happened, right? We use 0.8 mm nozzle. Let us assume we used 0.8 mm nozzle. So in that particular case, what will happen, layers will be much more bigger. In that particular case, will be not having that good of a surface finish, right? Next is gaps. There may be some gaps inside our model, right? In those cases, what we should do, right, after building my model, so those things are called as your post processing parameters. What are those things then? So material support removal. So when you have these supports, right, when you design these supports and when you print these things, you need to remove them, right? That is the first thing. So when we print, so when we make the support, right, the supports will be thinner than your model, right? If you are designing your part with a 0.8 mm nozzle, then maybe your support will be created in a 0.4 mm nozzle, or the gap distance, the layer thickness between your support will be much more, or the gap between your supports, right, two support structure will be much more, so that we are not losing so much material there, and we are reducing the cost. So in some of the most advanced machine, it uses two nozzles to put two kind of material. So one is your support material and one is your product material, so that it has that compromisation between both of the things, right? Those are some modern machines. Next, sanding or surface finish, right? Your surface finish will be very dull in the case of your 3D printing. So for that, what you need to do is you need to sand your part down, right? Sanding is an operation. And surface finish, right? So there are various operations to give very good surface finish, right? You need to do all those operations, right? One of the operations is what we use is chemical washing. You have acetone, right? When we have plastic component, what we do is we use this acetone to smoothen out my parts and clean them, right? So that is your surface finish or sanding. Next is your gap filling. So there are instances where because of some mishap, or you have designed a part for some certain application, there may be some certain gaps which are inside your part, right? In that particular case, these gaps are not good, right? Even aesthetically or functionally, these gaps are never good. So in this particular case, what you need to do, right? You need to fill those gaps. So we use some filler material to fill those gaps, and we'll give a smoother surface finish, right? And coating, right? If you are building a material in plastic and if you need to coat, right, even sanding doesn't clear out some of the surface finishes, right? And after gap filling, what happens is even if you sand, so there are some layer separations that are visible. So in that particular case, what you can do is you can coat your entire model with rubber or some other polymer, and even paint will come under this coating. So you can paint your model too, so that you have some certain color contrast between all those things for aesthetic purpose or your visual purpose, right? And in the case of functional purpose, right, if you want your material to be conduct heat very well, you can coat it with some metal alloys, right? So all of those things will come under this post processing parameters, right? So after this post processing, what we'll do, right? So we'll sorry right so next is our materials, right? So in the beginning, what you need to do is you need to choose your material. If you are 3D printing some particular component, what you need to do is, right, is this particular material will withstand the load, or is it functional, is it cheap, right? If you are um, doing your modeling for some visual purpose, then you do not need to use metals or resins or this polycarbonate material, right? What you can do is you can use polyastic acid or polyamide, or what we say is nylon, or your PVC, or your polyethylene. You can use those things, and still you can, print your materials, right? Print your part. So some of the materials which we use in 3D printing, some of the common materials are, so plastics. We have multiple kinds of plastics, right? So most commonly used thing is PLA, which is polyastic acid, right? Which comes in the form of wire, right? In fused deposition modeling and the normal 3D printing that we do in our homes, right? We use this polyastic acid, right? For stronger components, what we do is we use this ABS material. So what is the abbreviation of this ABS? Acrylonitrile nitrile butadiene styrene. So this is the material, right? ABS. So next is polycarbonate, PC, right? When you want to have a very good material which is very strong in nature, and if you want a clear transparent part, then you can use this polycarbonate. And polyamide nylon, which is a black material that we saw in that iteration slide, right? So that is your nylon, right? And after that you have resins, right? Resins are liquid materials. So all these plastic that we mentioned above, right? So those will come in this resin form too. So what we can do is we can selectively, harden them, right? There are some certain resins, right? Like polyurethane, even polycarbonate has one kind of resin, and even PVC has one kind of resin. With UV light or with heat or with laser, what you can do is you can sinter those resin, or you can harden those resins, so that you can get the output product. And you have metals, right? When you want to, 3D print metal for a strength purpose, right? Always metals are, 3D printed for some application purpose, right? So in those cases, what are the metals that we use? We use stainless steel, right? Because it has a very good thermal conductivity and fusibility. Next is aluminum, right? Aluminum is cheap and it's very good for 3D modeling, and you can get aluminum very easily as in a powder form, right? Next is copper. When you want to develop some parts for thermal applications, right, then you can use copper. And titanium, right? When you are designing a part for very high thermal and very high stressful environment, for example, in the case of aerospace industry, right, all the materials which goes and within your engine or the booster, they are made by titanium, right? So these are the materials, common materials which are used in your 3D printing. So what are the next things then? So next are the applications, right? What are the applications of this 3D printing, right? So we talked about the 3D printing, right? Unconventionally, we talked about the design for additive manufacturing, and what are the parameters that is included, right? So how to design your component properly, right? Even though you are an entry level engineer or a beginner in 3D printing case, then how can you, use these things to, develop your 3D printing, right? Now there comes the topic where application. So you learned all of these things. So where to apply this? So what are the industries which will use this particular 3D printing technique, right? The one of the biggest, right, industries, your aerospace industry, right? Most of your jet turbines, jet engines, most of your nozzles, most of your exhaust, right? So I think most of you have seen it. So this is how some piping system, right, in your aerospace nozzles or jet engines will be, right? So if you want to manufacture this particular component, either it's very hard, right, or it's very costly. If you want to produce it very cheaply, it's very hard. And if you want to, you know do this with very fancy equipments, then it's very costly. So in those cases, what we can do is we can use this metal 3D printing, right? And then we can produce this particular part, right? So aerospace industry, right, it has a very large application on it. So in the modern time, if you want to go to aerospace industry, this is one of the very important skill sets that you need to include in your resume. Next, automotive field. Now in the modern field of automobiles, right, what is happening is we are innovating. So when we innovate, what happens is these kind of manufacturing techniques will come in, right? So as you can see, all of these parts, right, are designed for additive manufacturing, and these are 3D printed, right? These are the parts of some cars. So in the engine, even some of the components in engine, which is very intricate, right? At your exhaust, at your engine ports, or your inlet nozzles, all of those things are very intricate, right? Very complicated. So in that particular cases, what you need to do is you need to, take some special manufacturing methods to produce them. So that is your automotive application. So medical and dental, right? Now the medical industry, right, biomedical industry has a very, big application of these things, right? Like your skull caps, right? When you have an accident and this particular part of the skull is broken, then what we can do is we can scan this thing and we can 3D print this particular component, right? Your implants for your knees and heart stents, all of those things, right? All of those things are now manufactured by your 3D printing material techniques. Next, sculpting and art. Now I think 3D printing art is, becoming very popular too, right? We have a number of sculpting tool where we can, sculpt in your computer. So when we say sculpt, right, it's normally your clay modeling and kind of thing. But now with the softwares like Blender or Alias, what you can do is you can sculpt in your computer, and then you can directly convert them into STL, and then you can trim them, right? Architecture. So architecture field will have a very complex design, right? So they use some softwares to show those designs. But what happens is when you want to build those designs, right, when you want to test those designs, it's much easier for us to build a 3D model of those things and test them than, directly testing on computer or directly assuming some things. And if you are, so imagine like this, if you are buying a new house, sorry, if you're building a new house, it's much cooler if you, just build a model of it, right? If your engineer or if your architect will build a model of it, and he will show you, so this is how your house looks, right? Which will be much more, impressive. Next is jewelry. Even the modern jewelry field is now, into this 3D printing parts and applications, right? So yes guys, so these are the applications of your 3D printing and additive manufacturing. So one of the important topics that we have discussed today is your parameters, right? So make sure that you are, understanding those things, right? And yes, guys. So that's about it. Thank you all. So I think this session was beneficial for you.